Hello. Okay. Hello, everyone. So today I will represent for our team to present the synchronous and scaling mechanism for relays. And the next present will be smart vision for Wi-Fi detection by air. So first I will introduce you about a little bit about relays. You know that LoRaWAN standard has become popular and demonstrate itself for the long range communication. But there are some limitation. For example, if the end device in some scenario like end device has cannot reach the gateway because of the auto like under route, or they can have the auto by the walls. So that's why the relays in this scenario will have important role to forward the data from a device to the gateway. And I have some example in Vietnam. They are deployed several experiments with the water measurement using LoRaWAN, but they also miss some problem with the communication with gateway, because most of water meter was installed in the underground and or inside the metal box, so it's very hard to communicate with the gateway. So let's talk about the relay specification. The first ideas of relay have been introduced in LoRaWAN Relay's workshop, and then they were presented in the team conference in 2019, and the next the team conference also discussed more about the relays. And then in 2022, the LoRaWAN Alliance will release the LoRaWAN Relay specification TS011 for relays. And for more detail about it, this specification basically is the synchronous like LoRaWAN radio. This is the synchronous between the end device and relays. This the LoRaWAN radio is the long preamble. 1 second. The long preamble package that can receive by relays. Why relays continuously implement CAD is stand for channel activity detection. And after this synchronous between the end device and relay, the end device will send the normal LoRaWAN uplink, and the relay will forward this uplink data to the gateway. And also like the normal LoRaWAN uplinks, they will open the receive window 1 and 2, and it's also work for downlinks by open the RSR window, and from downlink package from relay can send to any device by RSR window. And for CAD, the relay can work in 2 channels. The first default channel when you can work with the CAD parallelly, and this parallelly of CAD should be shorter than preamble length of WOS package. And if the relay work with two channel, the CAD pairs should be shorter, like divide 2. And there are also has some results about this relay specification. If the CAD every 1 second with the 10 and device, the estimation battery very good, 10 years, but we see that it has some limitation in the number of device. As they say, below 16 and device, and also the relay frequency plans. And you can see that most of works for this relay CAD. You can see the 68% for CAD with the single channel, and for double channel the CAD up to 77%. So that's why we propose a synchronous and scheduling mechanism. So to implement this our mechanism, first first relay will broadcast the sync beacon package every period of time. This package will include the device IDs and timestamp of device, and whereby for number slot, it means that the number available slot for relays. And the end device beginning to start, they will send the LoRa link check to define that if any device can reach the gateway or not. If they cannot reach the gateway, any device will CAD with pairs per second to detect the sync beacon from relay. And after we see the sync beacon from relay, the end device will send the sync packet format like that. It's included by the rest of the end device. The uptime means that how many times the end device needs to send every day, and also the timestamp of end device, and the channel, the data rate of the next opening. And then the relay will send back the sync ACK format like that. It's include the device ID of any device to confirm that the relay will any device will available for this synchronous, and 4 bytes for timestamp slot, means that the next the time for next opening. Relay calculate this timestamp slot by it's depending on the number slot available, number of any device already occupied, and then it's work as the normal opening LoRaWAN. We send the opening at this time slot already defined. They send the opening later, but before send the opening before the time slot, relay needs to implement CAD to detect the opening packet from any device, and then they do like normal LoRaWAN packet. So to evaluate the power consumption, to estimate the life battery life, to estimate the number of maximum and device that can connect the relay. We assume the parameter of transmission data like that, with basically 50 bytes payload, SF dice, and duty cycle 1%, with the preamble length 12 symbol. And we calculate the average current of relay like that. You can see we comparing with the relay specificity as 0.1, we decrease so much the average of CAD current, because we don't continuously do the CAD. We also do the CAD in the scheduling time. And this graph demonstrates very clear about the reduction of CAD average curves, and it change so much following the pairing pattern. And for the maximum end device, we you can see that with F7 we can reach about 200 end device, and for example with F9 it's around 60 end device. And we also evaluate the possibility of packet loss, because we are decided to scheduling the relay, so it's very the packet loss or packet delivery rate will affect very much about the synchronous accuracy, like crystal oscillator accuracy. And for example with the accuracy plus minus 10 ppm, it means that after hours the time error around plus minus 0.26 seconds per hour. And to avoid this time error of end device and relay, we need to calculate the CAD periods before timestamp slot. It should be larger than the error of the crystal oscillator. And if because of scheduling, if we have good at the color rate with this error, the PDR can reach 10%, 100%. Sorry. So finally is our conclusion. So yeah, with the output proposal mechanism for relays, that's very suitable for some application requiring large number of end device, like smart water meter, and this device send data parallelly, and output this relay can work for multiple channel. And we also optimize the power consumption of the relay by reduce the CDH. And with the scaling mechanism, there is no complete array when you increase the number of end device. Okay, that's my presentation. And for the next time.
Okay, thank you, Mr. Trump. Thank you, Mr. Chairman. And I am Nguyễn Thảo. I'm from University College, and I'm very glad to be here at LPWAN'24 to share to you about our new device of Wi-Fi detection. And at University College, we have a very good opportunity to work with multiple companies like Dolphin, IRT, and EchoStar to make a new device, what we call Smart Vision IoT, and the application we are working on is Wi-Fi detection. So I think we are a bit late in the schedule, so I'll try to go quick, so everyone can go grab a coffee. So the project name is Elliot, and the main component in the device, of course, AI camera. So Dolphin is they are on doing their own chip with AI accelerator inside, and it provides the high AI performance, which is from 10 to 100 giga operation per second. And with this much of power, most of the application using AI for IoT will be feasible. They also pronounce that the record-breaking energy efficient they can reach is more than 2 teraflop of operation per second on each watt. So this is equivalent to probably 10 milliamp when they are running the AI models. So for the communication, at University College, we developed a terminal that be able to connect to the space communication. For your information, we are working with EchoStar, and EchoStar they have the geostationary satellite, which is like around 36,000 kilometers above the sea level. So they provide seamlessly communication to the IoT device, no interruption, no prediction needed, so you can send whenever you need. And in the device, we integrate the CB and span antenna, so we have the better alignment of the device compared to the satellite. And the application for this device, not only the Wi-Fi detection, as I mentioned above, because we have a high AI performance, so we actually can apply to cattle tracking or meteor station or other application. I think it's all feasible. So in terms of the terminal or antenna aspect of the device, so in the antenna, in the terminal here we have, so this is the actual terminal. The size, the dimension of the device is only 10 by 10 centimeter. And we integrate multiple antenna systems into this. So we have the sub-GHz for LoRa terrestrial network. We also have S-band antenna for space or satellite communication. For location for GNSS, we have the antenna for 2-band, L1 and L5, so we got a better location of the device. And all of these antenna is circular polarization. So as I said, better alignment. Oh,
no battery.
is that? I think I can go without a microphone. Maybe it's better. So, as I said, better alignment of the device when you place it on the ground, and yeah, thank you, thank you. On the device, we also have a few basic sensors for the environment also. So we got humidity, temperature, accelerometer, and here you see. I think Professor Ferrero put a
Radiation pattern.
yeah, the radiation pattern, and we can reach the gain of something like 6-7 dBm. Yeah. For the power, we integrate the solar harvesting system. So when we deploy the Wi-Fi detection in the middle of forest, basically because we have the connection to the satellite, we already have the independent to the terrestrial network, so we can deploy anywhere. The remaining question is the power. How long do we need to go there to replace the battery? How long do we need to maintaining or etc. So we integrate the solar harvester inside with a solar panel all around the device. So higher reliability. For now, the device is estimated to work 3 years. Totally possible. Okay, so here we got the block of the device. So basically you see on the left side, the yellow will be the power, the purple part is the AI camera, and the red one is the transmission terminal. to the satellite, and the green part is the RF part in the device. In terms of application, we've been working with the city of Montpellier. So they have a wide area of forest there, and they want to monitor the wildfire. So basically, what we do, we are working with the firemen in the Montpellier. So we will deploy 10 devices, 10 terminals in the watchtower. So basically, we replace the man in the watchtower with our device. And from the camera, we separate the frame into 24 subframes. So whenever we detect the fire or the smoke, the device will report, okay, which frame is having the smoke or the fire. And then from that, we can calculate the relative position of the fire. And no, sorry, that's the next step. So just to tell you that here I bring the first prototype of the device, and to give you a quick demo of how to do it. And to give you a quick demo of the device. So just to tell you that I replaced a lot of components to do the demo indoor. So basically here, instead of the fire, I don't want to give a fire here, we detect the hand gauger. So we got this one we call the palm, the victory, and the close. So the camera will take the picture every second, and the device will do the statistics for every 10 seconds, accumulate how many detect of each gauger, and then it is sent to the gateway over here. Instead of the satellite, we don't have a satellite indoor, so I do with the terrestrial gateway, and it's transferred to the network server and display to the application. So the device is right here. So if I came here and give it the gauger like this, it will show on the Grafana dashboard. I think I will leave the device here. So in the coffee break, if anyone interested, we can stop by, play with it, discuss about it. Okay? And it's my presentation for this part. The last part, I will give back to Professor Ferro, and he have a interesting, important message to everyone. Thank you.
Just before moving to the question, we are organizing a conference in Da Nang, Vietnam, in the middle of October. So it's still possible to submit a paper. So the conference is mainly about connectivity application. So it's perfectly fit with all the presentations that have been given today. So if you're still interested, it's still possible to submit an abstract, and the final paper is expected for mid-September. So if you want to visit the beautiful city of Da Nang, please send a paper.
Thank you for your